All right. Hi, guys. Welcome to the third episode in our series, in my C# coding challenge series. My name is Idowu Akinde, and like I've stated in the first and second episodes, quick distraction. So, if at first you don't succeed, do it like your commander-in-chief told you to. All right, so, that's an inside joke. If you don't get it, you don't get it. So, like I said in the first and second episodes, my intent with this series is to reach out to aspiring programmers and software developers. When I say aspiring, I mean students who are in any of the upper hundreds of Nigerian tertiary institutions who are studying a lot of theory about computer science, but who don't know how to write computer programs. So if you're a student in a Nigerian university, this is meant to reach out to you. Over the past couple of years, through many outreach programs and mentorship programs with university students, I've come to discover that the biggest challenge that I have is lack of physical presence, lack of time to be able to mentor them one-on-one. Whenever I'm able to be with them, I get the feeling, I hope so, that those sessions are always very valuable to them. However, I'm not able to stay on any single campus for long, and so, and talk less multiple campuses, and so I have been creating these series of videos that help students and recent graduates of computer science, and anybody, in fact, that has an interest in learning how to write computer programs the modern 21st century way, to pick up those skills. So that's what this series is about. And this is the third episode in this series. In the first episode, we tackled a popular programming challenge that is often thrown at candidates, software development, programming, candidate positions, candidates at interviews in tech firms. The first was the Mars Rover Challenge. In the second episode, we covered the Fizzballs Challenge. And in this one, we'll be tackling the Anagram Detector Challenge. This is the problem statement here. The problem statement states to write a function that accepts any two strings as parameters and returns true or false based on whether it was able to detect that those two words that were supplied are anagrams. Okay, so the second sentence is just like a tip, which says that just to focus on the task at hand, limit the number of acceptable characters to the ASCII uppercase A all the way to ASCII uppercase Z. Uppercase A, if I remember my programming days, should be ASCII 65, and uppercase Z should be ASCII 90. Having said that, without much further ado, let's get cracking. So the first thing that I need to do is to share the desktop, and I think that is my Visual Studio running. Oh, not yet. So let's create a new project, console application with .NET Core. Let's call it the Anagram. Okay, the Anagram Detector. I will place it in this folder, this special folder where we have these other guys. Okay, and then create. Restoring packages should be done in just about a moment. Okay. So for those of you that remember or that saw the first few episodes that remember, I have a habit of planning my work before diving into code. I think that programming is a tool to solve problems and not an end in itself. So the first thing we'll do is that we'll try and analyze this natural language that the program statement has come in and try to infer what is expected of us, infer what's expected of us. So the first thing here is that accept any two strings, return true or false, depending on whether the two words, the two strings above are anagrams. Okay, and then return true or false, depending on whether if they are false or not. For simplicity's sake, focus only on strings composed from uppercase letters. So if I call those acceptance criteria, I'll say limit acceptable characters to A, or if I say this is the range A to Z. And if I remember clearly, this should be 65 to 90. And then remove all spaces. So we can call that trim, or we can just use the replace function. Now let's define anagram. Okay, so if we come here and we search for, what does this tell us? What's an anagram? Anagram is a word, phrase, or name from a range of letters of another word, phrase, or frame, such as SPAR formed from RASP. So SPAR and RASP are anagrams. Okay, so what does that tell us? Not so much. Can we also see what Wikipedia has to say about that? Okay, so an anagram is a word or phrase from a range of letters of another word, typically using all the original letters exactly once. There, for example, can be arranged to Nagaram, brainy to binary to brainy, Adobe to abode. Subject, anagrammatist, blah, 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 blah. Listen to silent. Anagrams will be created as a commentary on the subject. Rail safety to fairy tales. Interesting. Roast beef, debit card to bad credit. Interesting. New York Times, monkeys, right. Okay, so evil, vile, angered, and rage, synonyms. Space may exist, like we've already identified that we want to remove the space. Evil and vile, which is like synonyms, part and tap synonyms. They're also antonym. All this is a digression. The key thing is that we understand that anagrams are formed by rearranging the letters. So what our program wants to detect is to verify that the exact same sequence of letters, the exact same letters in their, not necessarily in their combination, but in their occurrence is consistent. The occurrence of the group of letters that form each one word is consistent with the second, with the other word. That will give us an anagram. Therefore, can we have a plan of action over here that says limit acceptable characters? That's not even important right now. So permit me to do this. We can come back to that. Okay, yeah, remove all space is important. The next thing is perhaps in order to determine that two words are composed of an identical combination of letters, perhaps what we need to do is to sort the letters of each word. Okay, and then after sorting, compare the sorted words, and if they are equal, you should have an anagram. So let's try. All right. So after defining our rules, or what will become essentially our acceptance criteria and therefore our test methods, we can come here. Oh, excuse me. We need to create a test project. So if I say add new project, xunit test project.net core test, and give me a create. All right. Again, if you saw my earlier videos, you understand that this is a convention that I have. It's not unique to me, but many people in the industry do that as well, and you will see where it makes sense. Oh dear, how did I do that? Okay, and then we can, say all sorts of things. We can, just to return our first red, we can say return true, and then we can say assert dots. So the true false. Okay. Again, we have a. Oh, you have been downloading. I see. Okay, thank you. We'll start later on. Public void, return true. I was going to insert here, oops, arrange, act, assert. Okay, so it just so happens that this is a very simple test, so we don't have arrange and act for this method, but the assert section is already in what we've done. So if you come here and so the unit tests, which if you just, in case you don't have, you go to view, pads, unit tests, we open that up. If you tell it to run all, you should have that. Okay. And any moment from now, we should have, so it's still running the tests. You can see the build status is still, okay, so it's done now. And you can see that we have a red anagram detector. So if you look at this naming convention, anagram detector says that anagram detector should return true. That's where the semantics there make sense. And we have a red here, red all the way. Okay, all it will take to turn this to true is to do this. And we have what I call a cosmetic true. If we tell it to run it all over again, it should be faster this time around. Because all the scaffolding is in place. There you go. We've got a green. We converted a red to a green, okay? Even though it's a cosmetic conversion. So the next thing is so we've already assumed, we've made an assumption here that just by having this name, we're going to have a class called Anagram Detector. That's how TDD kind of works. Excuse me. So if we come here and say add new file, I want to insert a class, and I have Anagram Detector there. that'll give me this brand new class with methods that I will use to carry out my assertions over here. So if over here I define my string first word and my string second word, and here I accept okay, all I have to do here is to assign, oops, oh dear. All I have to do here is assign my local fields to the incoming values. Capital equals lowercase. There you go. Oops. Thank you, Visual Studio. All right, now I need a second method. I need a method that, according to our requirements here, returns a true or false. So this method's return type should be bool, and perhaps what does this method do? It returns true or false depending on whether or not. So I can say is anagram or are anagrams. Okay, and I have to take again the first word the second word. Oh, of course. Okay, so return type is bool. So I'll do this. Then if you remember my previous methods, I explained this rule of thumb that I have, that for every method or every function or any, whatever I'm writing that returns a value, in order for me not to forget or spend a lot of mental energy remembering not to forget, I just have this rule of thumb. Whenever I'm defining a method with a return type and a return variable, I quickly set up these two things. A return variable at the top of the method and a return statement at the end. In the middle, I can do all the somersaults that I want. So public bool, blah, 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 blah. Okay, so that's just rubbish. So this guy over here, so for this, just to connect these two guys together, anagram detector here by default should return, return a false, but according to our requirements should return a true if it is so and a false if it's not. So can we, since we're returning ret and ret has been set to false, it means that this guy will become false. When we come here and we tell it to return, okay. So over here, I'm going to do something like anagram detector, oops, dot R anagrams, which, I'll come back to that. You'll see what I mean in a moment. So under arrange, if you remember what arrange does, you define your words. Give me an anagram word. We just saw Adobe, right? And we just saw abode. Okay. We also need to create an object that will hold, so we need to use the constructor on this guy. Excuse me. That doesn't need to be public. And then in here, I can have word 1 and word 2. Okay. Type could not be found. Of course. So this happens whenever you add a new unit test project. First of all, in order to have the same, I need to go to dependencies, edit references, add this project. Okay. Having said that, using Anagram, no. Let's take this out and then using Anagram Detector. Okay, so we're taken care of. All right, that's perfect. So under act, I can define a variable here and say bool ret equals. Now this is why I said you would understand. Okay, ret equals da 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 da, which is calling this method, the other method apart from the constructor. Are anagrams, and it takes the first word and the second word. So it's going to be exactly that way again. Oh, so if you think about this, this is repetition. I don't need this because I have those values set internally already in those internal fields. So this is perfect. Okay, true, ret. Okay, all right, so let's go. Can we test? I expect this gentleman to get me a false all the way from here. Okay, here, technically, effectively here. So if I go back to my unit test and I run all, I expect to see a failing test. Anagram detector should return true, but we have a false. Thank you. And in order to make it green, all we have to do is change this to true. And it will become green. So that's the first test method that we'll write. We'll come back and beautify or refactor it, sort the letters of each word. Okay, so that's the result. It's green there. That's fine. I'll come back to that. So the next thing we want to pick up is remove all the spaces. So somewhere in our test, I have to copy the fact as well so I can see. Public void. Do I want to return true? No, what I'm doing in this case is that I am spaces not contained. How do you say that? No space within should contain no spaces. Okay, so arrange okay, um, so the first thing I want to do is analyze first word. And then do the second. Okay, so actually, why am I analyzing? What am I analyzing? I think C# is advanced. I should just say um, first word dot replace, thank you, old car, new car, space with empty string. And that should be fine. That should be fine. Okay, and that satisfies this condition. But how do I test that? So somewhere in here, I already had contain no spaces. So I can say, what was the other one? It was real safety, and then fairy tales. Okay. Hmm. So these conditions are different. So I need to separate this out. Boom. Again, I want to return a true and false depending on whether the word is is whether the word contains a space. So okay. As soon as we're dealing with plurals here, again, oh, of course. Hmm. Okay. So the key thing we want to do here is to both ret equals false, return ret. Key thing we want to do here is just check for the existence of a space. So I can say first word dots. Should we go as far as to use link? Okay, so 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 somewhere here we're testing for remove all spaces. Okay, so if remove all spaces, if you do remove all spaces, then check the values. Okay, so let's make this public. Okay, so we got that. So essentially, index of should give us the position, the zero-based index of the specified character in the string. So, and if it's a -1, it wasn't found there. Okay, so we can use index of. The other alternative is to use substring, which will give us the substring starts at a satisfied. We choose a substring, blah, blah, blah. It's a bit complicated. Let's just use index of. It's more straightforward. Index of, and this will be the car. Space as a car. Okay, so what does index of return? The zero-based index. Okay, and when no, 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 no. No, I don't want to cast a ball. So when you return this, if I remember well, it returns a -1 if it's not found. So if you do that, essentially -1 and -1 will give you a -2. The best case is that you have 0 and 0, in which case, or is that you have, yes, that you have a 0 and 0, which tells you that, yes, there are spaces in both of them. So anything below a 0, for the sum of them, this and this return that all of this is less than 0. So if you sum those things up, so I have 1, 1, 2, 1, 2, 3, 4, another. Okay. So first word, second word, that should do it, because this would tell me that there is a space in there. Okay. So let's try. Let's try. See what our test result says. Okay, contain no spaces, contains, expects a true, but it got a false. Can I investigate further and see the values of my variables? Okay, so instead of this, in order to see it properly, I could say I set a watch on that. So if I do the method returns -1 if the character is not found. Just wanted to confirm that. Okay, so real safety exists. There's a space in there. So space should have been found, and it should have been found at 0, 1, 2, 3, 4. So 4 plus 5, 0, 1, 2, 3, 4, 5. 4 plus 5 is 9. And is 9 less than 0? No. 9 is greater than 0. So it should have given me, this should have been a greater than. Okay. Let's rerun. Something's gone wrong. Oh, okay. Contain no spaces. And if I do this, what do I get? Actually, what did I just do? I just inversed the previously correct solution. So now that there are no spaces, and my condition is contain no spaces, so when there are no spaces, it should be true. It should return a true. And so -1 plus -1, which is -2, should be greater than 0. No, should be less than 0. If -2 is less than 0, then we should have a true. Okay. Oh dear. Sometimes these things kind of twist your brain. Come on. Is there something going wrong here? Oh, okay. So if I go back to this, I think I'll
It's 8 o'clock.
Stay away from that rebound. Contain no spaces. Meanwhile, it does contain spaces, so that's that. Okay. And the next thing is that we want to sort the letters. So there's a way to test the sort, really. So we'll skip that test and then compare the sorted words. So my next test, if I'm really doing TDD, should be, instead of contain no spaces, should be are equal. So here I have to reintroduce, and then I have to say, right. Okay, so I need to define just not to confuse this with the are equal in the standard .NET Framework class library. I'm going to change that to are the same. So let's go here and write another function. Okay. So if you want to check if things are the same, essentially that they contain the same sequence of strings. Okay, first of all, check that the two strings are the same length. Check that the loop through each string. Check that the each word is okay. So I need to change all places where I've used string, word. So that's that. Check that the two words are the same length. Okay, if first word dot length okay. So far, this is what you call a provisional true. Mm. Okay, remove all spaces. Okay, so for I less than first word dot length 0 to length minus 1 or 1 to length. So less than is fine. Okay. Check that the corresponding letter is equal to its counterpart in the second word. If first word, mm-hmm. Oh my God, we haven't sorted. Missed something out. I haven't sorted. Just because I skipped the test for sorting, I unconsciously skipped the implementation of the sorting. If I, first word I equals second word I, then do nothing else. Once you get a false, then return. Once you get a mismatch, then they are not the same. Otherwise, every time you run through, you will always get a true. So here we start. Excuse me. Hello guys, welcome back. Sorry, I had to take that break. If you're in Nigeria, you're no stranger to infrastructure issues. I had to relocate, so I'm at a location now where I cannot share my video, but let's just quickly round this up and then we'll call it a day. All right, so we were trying to sort, okay? I think that a better way to solve this is to have a separate method for that sort. And I'll call it sort, which will do exactly what I wanted to do in one line, but is apparently not feasible. Okay. So our code paths return a value. Excuse me. All right, so sort string, the first thing we want to do is exactly what we did here. So let's create a variable to hold a character array to hold our to hold our, oops, come on, what's that? To hold the result of this. We can then sort one second. Okay, so what do we have here? We have created a character array, a car array, not a string array, an array of cars that contains each letter of the word under consideration. The next thing we want to do is that we want to call the sort method on that array, and then we want to say, we want to assign that sorted array to our return value, so that when we come here, and so that when I come here and I say, like I was trying to do earlier on, first word equals sort word as string, okay, the same thing. Oops. That should take care of my sorting problem. And we already have this other side that takes care of the comparison. Okay. So we had this thing called are the same. Are we still good? Are we still called are the same? Yes, we are. File, save all. On our test method, what we are now testing is if this guy is the same, then tell us so. So we have a lot of cobwebs here. This has become cobwebs. Readability is one of the most underrated things, very important in programming. So this too, because it's a utility method, should probably be at the bottom below others. Okay. So if we run a test with this, oh, so right now we have what? What do we have? We have one passing test and one failing test. Okay, let's just go ahead. We'll come back and you know, make it all rosy later on. So now we have 3 tests. The basic one we started with, return true, the one that tests for no spaces, and then this one that tests that they are comparatively the same, and implicitly that it has been sorted. So comparatively the same is telling me, is giving me a pass. Can you see that? Should are the same. You can see that my grammar is off. So let's fix that. That's the purpose of the should clause. Should be the same. Okay. And in this class, so that's over here. All right, so when you run that, if I deliberately turn this to an X, which asserts that they should no longer be the same. If I run this, what do I get for be the same? Be the same is still true. Ooh. So let's debug, let's step through, okay? Be the same should not be true. Okay, all right. Okie dokie. All right, so be the same is not true now. Well, the only way is to get visibility into the code as it's being run into each of those variables. And that visibility comes from the debug workflow. So now I do that, the better. Now be the same should not be. Shouldn't be. Okay. So let's find out why it is so. If I put a breakpoint, excuse me, get back up there. If I put a breakpoint in this place, just to be sure of what is being returned, back to sort string, that's one. I will have visibility into first word and second word when they're being assessed. If I also put a breakpoint, if they're not the same length, okay, so that's when we had a false. When they are the same length, okay, something happened here. Fault is from somewhere in here. One way or another, we're gonna inspect these guys. So where's my debug? Okay. Since I'm ready to go live, I might as well call this guy. So instead of console write line, I can say oh dear, I need to create an object. I can say console write line. So how do I define that? No, that would be my program CS. Please stay there. Thank you. And this should, this is an A. This should settle me. Okay. Okay. Been a while that I did anything with the terminal. Cleared the screen. Okay. Rail safety. AAE feel resty. So that's for rail safety. All right. I wish I could copy this. AAE feel resty. All right. Step through. And then we have again space AAE feel resty. That's because they have the same set of words. Okay. So where are we? I0. And we're comparing spaces. Okay. So, all right. What this means is that this removal spaces did not work. Okay. All right. So we'll come back to continue to debug, but the first thing we need to do is to so I will quickly do and then if we run this again, looks like the space has not been deleted still. We still have it. $11 characters, 11 elements in our array. So now ret is true. Okay. All right. So it looks like we have progress now, okay? So this self-assignment is what we were missing in removal spaces. Okay, that's a warning, that's a long story. So here we have the spaces have been taken out. If we continue, the other one too has the exact same sequence of characters. And when I is 0, and we're comparing so first word is AAE Floresti. Second word is AAE Floresti, exactly the same. Okay. If we check that the 2-car array, that would be A equals A. Can I add that to watch? Oh yeah, there you go. All right, thank you. And second, as you can see, they're both the same. Okay, so what would this do for us? We can always see that they are actually the same. So if you keep going, AAEE, so it's true. It's always true. See, what was the last letter? I can't remember. I think it was a Y. So after the Y, they're the same. So they're the same. So what did you return? Oh dear, should have put a stop here. Let's just run through it quickly again. Okay, so the output is true. All right. I can actually stop it because we don't have time. And I can set this, what's my variable? In here, I can take this, if I take this to X, and then run it again. Error, how? Really? First word. Okay. So now they're not true. S is not equal to T and T is not equal to X, but Y is equal to Y. So we're overriding the initial. Okay, so we need to break anytime we get a false. We need to run out of the loop because one false is enough to break, is enough to fulfill the condition of it not being true. Because if we get a true after we've got a false, most likely it will invalidate the value of ret will be overwritten and it will invalidate all the work we've done. So in here we need to say return. Okay, so let's run it again. Okay, so first word is AAEF Philoresti. Second word is AAE Philorexy. So they are different in their third and second to the last letters. ST for TX. ST in the first, after R, between R and Y, TX between R and Y. So we're expecting to have a false where we have an S for a T. Okay, and that's it. False. So thank you. Let's try it now. Um, so if we do this, be the same as false. If we do this, be the same as false. Okay, yes, because we don't have the same length. If we do this, be the same as false. Okay, but if we say go back to this, be the same as true. All right, so all looks well. Just to be sure that we still do need this guy because we introduced it during our troubleshooting phase. Okay. I doubt it. Pow. be the same as false. Okay. Come on. Okay. Remove all breakpoints. Thank you very much. And that kind of summarily rounds up our challenge today. Let's just do some house cleaning and make this whole thing presentable. Okay, so let's really look through our requirements. Limit acceptable characters to 8 to 90. We'll do that in just a moment. We suppressed that in order to make progress. Remove all spaces. We did that successfully. So sort the letters of each word. We did that successfully. Compare the sorted words. We did that successfully. Okay. Acceptable characters. Okay, so I'll leave this to you guys. You guys should go and exert, explore your curiosity, find out how to limit these, the range of acceptable characters to uppercase A, to between uppercase A and uppercase Z. That'll be your homework. We're really, really, really pressed for time here. And we're pretty much done here. I just want to see this test. Excuse me. Return true is still false. So if I come here, anagrams, Adobe abode, go to declaration. This is the one that we have been manually assigned. So here, if all of these conditions have been satisfied, so the anagram detector is in the be the same. So ret equals this is it really. So whatever you were, even if we started out as a false at a value of false, be the same when we I'm really tired. Cognitive capacity. Shut up. All right, so ret equals that runs this, which is where all of the logic that we're employing to solve the problem resides. So if we do it again, we should have 2 passing tests and 1 failing test. The 1 failing test to be this. Return true is correct. Okay, and be the same is still failing until we deal with this. So just to be mischievous here, I'm going to replace this with Adobe and abode. And I'm going to do that. Ooh, we don't have to do that. So we'll run the test. Alrighty. Let's see it give us an answer. Adobe is not equal to false. Oh, of course. The condition is in the test. The condition we wanted is in the test, but the code reflects something else. That's this and this, which are false. So what I should have done is this, which would have given me 3 greens. 3 greens, 3 passing tests. Alternatively, I could have just suppressed this. Okay. First, let me return those guys, and then I could have just suppressed this. So that we have only 2 tests. Okay, so there lies the third one being the ASCII character clause. We've done spaces, we've done sorting, we've done comparing. We agreed that sorting will be difficult to test. So there you have your anagram detector running in command line. You can give it a visual or graphic interface if you want. And that's that. Once again, thank you for your time. Thank you for your attention. And if you know any rookie level person who wants to learn programming and or the basic elements of the beginning part of a software development career, please share this video with them. Once again, thank you very much. Bye.